8 misleading statistics, and in this lesson you learn to recognize when statistics and graphs are misleading. Let's take a look at this example. During political campaigns, politicians often use statistics to make a point. In recent election, opposing candidates represented the two graphs shown below. Okay, and you have graph 1, which looks something like this, graph 2, which looks something like this. First question, do both graphs show the same information? And second question, which graph suggests a drastic cut in government spending? Which graph suggests fairly steady spending? Okay, let's answer the first question. Okay, and this is a graph about Governor Doolittle spending habits. Okay, graph 1 and graph 2. And if you notice, even though they look different, both graphs represent the same data. They were graphed from the same, using the same data, but by using a different scale, each candidate was able to take the same information and tell a very different story. In graph 1, the scale was 0 to 300. Look at graph 2. It's 216 to 228. Okay? So, what does that mean? Okay, so in this case, if you look at this very carefully, graph 2 is a result of an expanded vertical scale. Okay, for this reason, graph 2 is visually misleading when compared to the complete scale in graph 1. This should be indicated by using a small break in the vertical axis as shown at the right. Okay, this break that we're talking about. This shows that the axis is not to scale between 0 to 220. So if you create a scale, you will tell the person reading this graph that this is not drawn to scale, because 0 to 220 will have a different interval from 220 and 222. This will prevent your graph from becoming misleading. Okay? Let's take a look at example number 1 and see what a misleading graph is. The graph displays the same data. Is graph A misleading? Explain. Let's look at graph A. Okay. Obviously, there are a lot of questions you want to ask in graph A. Therefore, this can be misleading because there is no title on the graph. There are no labels, okay, on either scale. It should also include a break in the vertical axis between 0 and 30. So graph A is misleading. But if you take a look at graph B, okay, has a title, has labels in both, starts with 0, intervals are fairly the same. So graph B is not misleading. The scales are labeled and the graph includes a title. Okay? So graph B is not misleading because it has all the necessary requirements to be fully understood. Good example. Example number 2, the results of a class survey on weekly allowances are shown in the table. Felipe told his sister that the average allowance was $7. Megan told her parents the average was $5. And Alba told her brother the average was $4.45. How can all three people think they are correct? And letter B, which do you think is the best measure and why? Actually, all three people are correct, simply because when you talk about what they used as a measure of central tendency, it all makes sense. Let's look at letter A. Each person used a different measure of central tendency to describe a set of data. Felipe used the mode. So Felipe used the number that occurred most often, and that's why he said 7. Okay? Because if you look at the mode, 7 occurs the most. Okay. Megan used the median. So if you arrange all these data, when you talk about arranging all this data from least to greatest, it's not just 1, 2, 3, 4, 5, 6, 7. Okay. It's a number of times it appears. So if you arrange this set of data from least to greatest, this would look something like 1, 1, because there are 2 1s, 2, 2, 2 2s, 3, 3, 3, 3, because there are 4 3s, 1, 4, 5, 5, 5, 5, 5, because there are 5 5s, and so on and so forth. Okay? And that's how Megan was able to get the median, and Alba used the mean, meaning adding them all up. How do you add them all up? It's not, again, simply as 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. It's 1 times 2 plus 2 times 2, 3 times 4, 4 times 1, 5 times 5, plus 6 times 0, plus 7 times 6. And then divide them all by the total number of pieces of data, which is 11, 13, 17, 19, 21. Divide them all by 21. And that's how Alba came up with 4.45. Okay? Second question is probably more important. Which do you think is the best measure and why? The mode is misleading because 7 is also the highest allowance. So you cannot use mode if it is close to the highest or close to the lowest. The median is misleading because 5 is the second highest. So again, the median becomes misleading because again, 5 is close to the highest. If the median is also close to the lowest, you cannot use the median. So the only measure of central tendency left would be the mean. Okay, so Alba was probably the most correct in terms of representing the set of data that was presented in that table. Okay, lessons done, and on Google Forms, type a summary of what you've learned and type a question you might want to ask in class about this lesson. Thank you.